So this is my $66 FrankenPi. You can see this is 720p video on a computer monitor, but it does just as well on a 50-inch TV. And I'm gonna, originally I had some overheating problems. In order to have smooth video at this level, I needed to overclock, and I had some overheating problems, so the FrankenPi was my solution. I'm gonna show you how I did this. Okay, so these are all the parts. Basically, these are the pieces for the case. That's the bottom, the two sides, the top frame, and the top cover. And this is the heatsink that originally came with the Raspberry Pi. The 16 gigabyte memory card is actually the drive that the Pi operates off of. And this is the Pi itself, okay? It's a credit card sized computer. And it uses what's called system on a chip. That's the advanced heatsink that I put on. I got a pack of 8 for like, I don't know, $20. You see, I got some leftovers there. And I put that on. The other heatsink, that's the video chip itself. But it has Ethernet, 4 USB ports, HDMI, sound out if you don't want to use the HDMI, and that micro USB is actually where the power comes in, and then that's a standard adapter. These Raspberry Pis are very flexible and useful in a lot of different applications. And in this one, I'm just doing a home theater PC. So the whole kit for the Raspberry Pi, without the fan or the extra heatsink, was about $60. And then the fan, I think, cost me $2.50. But the thing is that the Raspberry Pi will throttle back the frequency of the CPU when it reaches 80 degrees Celsius in order to protect itself. And when we were having all that heavy video going on, we were easily reaching that with the standard heatsink. So I went out and I bought the modified ones. Those are pure copper and obviously more surface area, and it did help some, but it was still getting up to 80 and running at about 82 degrees. So we needed further cooling, hence the fan. So I'll put this back together and show you what temperatures we're operating at now. But for this whole thing, $66, and I cut the cord, and I don't pay for cable or satellite anymore. Okay, we're partway through the assembly here. I wanted to show you, see this this fan is a 30 millimeter fan. It's a 5-volt fan. I drilled I got a hole saw of 1.25 inches. It's slightly larger. It's actually 32 millimeters. So it left a little bit of a gap around the edges, hence the tape. But there's you can barely see it, but there's a little bit of Gorilla Glue on the corners there to hold it in place. And the tape is really just to seal the hole where there was gaps, so that we draw all the air through these 3/8 inch holes that I drilled. Let's see, and then you can see the fan is connected there on pins 2 and 4. There's the pin out for the Raspberry Pi. You can see pins 2 and 4 is the 5 volts on the ground. And then we're going to put the rest of this back together and show you how. So we've got the Pi running again. I don't know if you can hear the fan, but it's not really very loud. That's the desktop. I'm going to show you. So I've got YouTube TV. That cost me $35 a month. I'm already a member of Amazon Prime, so I can watch Amazon videos. These are from my digital movies. I have a pretty extensive set of ultraviolet movies, and Vudu does not work on a lot of applications on the web. This Raspberry Pi runs off of a Linux operating system that is designed specifically for the Raspberry Pi, so everything works real well right out of the box. And So there's Movies Anywhere and Fandango allow me to still watch my digital movies. And of course we have Netflix. Kody's another thing we can get into, but there are a ton of add-ons for Kody. It's really just what you want to watch, but it's another media center application. So we're going to go to YouTube TV. That's $35 a month, and I get about 40 channels. $10 for Netflix. I'm already a member of Amazon, which is about $10 a month. So for $55 a month instead of $150, I got everything I want when it comes to watching TV. So again, I'm not going to set the world on fire. It's not the fastest thing in the world when it comes to surfing the web. You're not going to do supercomputing on it, but it does the job. All right, this is going to go back to the tennis. All right. And again, you can see it's moving smoothly. It's not herky-jerky. Again, this is 720p. Usually in slow motion is when you see the real jerkiness, and it's just not there. But that's because I've overclocked it. And I'll show you those settings in a minute. Hard to get this screen without a glare, so forgive me on that one. But all right, so the real interesting stuff starts right here. So this is the memory. You can see the memory is 192 meg. There's a total of 1 gig of system memory, so I'm taking a little bit of that for the video. And I know it sounds like I'm a real computer nerd who sits around all day and hacks away at the computer, and I do for work, but not, it's Excel. All of this that I learned from the web and the Raspberry Pi community. So it's really not that hard. And I started to bump up some of the frequencies, the GPU from 400. I left what the defaults were so that you could see. I bumped up the CPU from 1200 to 1350. All these memories have been increased. Of course, the over voltage to handle the increased frequencies. And I also reduced the minimum increased the minimum frequencies. So instead of only going down to 600 and 250, now it's not allowed to go below 800 and 300. When you do all these, if you're going to get a overheat warning, it's kind of an annoying little thermometer that comes up, and I disabled that. You can leave it on there, but you'll see now there's no reason for it. But you don't want to force turbo when you have overvoltage set, because you'll void the warranty for the Raspberry Pi. So, all right, I'll show you the temperatures. We're still running our full screen video. I just have it silenced for now. And it's been running for about 10 minutes, so it should be up to its normal temperature. Playing, and we're gonna. One of the cool things about the Raspberry Pi is you can set up a thing called SSH, where you can actually go into command line on the Pi from another computer, so that you can allow all this to still go on, and you can run your full screen video, and we can watch the temperature and see how it does. All right, so we're at 49.4 degrees Celsius. It updates about once every 2 seconds. And you can see it's stable. It's not going up. Well, there it goes up a half a degree. Now a full degree, but then back down. All right, so it hovers right around 50 degrees, even when it's dealing with some of the toughest video. It never gets above 60 degrees anymore. So usually it's hovering right around 50. I can work it as hard as possible, and it gets up to maybe 60, but nowhere near where it was at 80 degrees. That means it's not throttling back, plus it's overclocked, and you've got a $66 home theater PC.